So yesterday we used the command method to enter some command in the starter. That's basically the summary statistics, the correlation, and we run a simple multiple linear regression. I think that's all we did yesterday. Before we proceed, is anybody having any question concerning what we did yesterday? Maybe you have tried it out, you had a challenge, or there's something we needed to clarify. Anybody? The floor is open. Okay, in absence of that, I'm sharing a quick, yesterday, we ended up on, should I call it a rhetorical question? I was not demanding for an answer per se. When I asked what would be the most appropriate regression method for the for predicting the outcome of a football match, knowing fully well that the outcome of a match is either is 0, 1, or 3. Am I correct? That's where we stopped yesterday.
Yes.
Right, yeah. Okay. So, and we actually ran a linear. We ran a linear regression, but I wanted to also be sure that whether that is the most appropriate method to use. But if you look at what we are doing today, I said econometric note on common types of dependent variable. The first, when your dependent variable is continuous in nature, if you have a dependent variable that is continuous in nature, do we understand what we mean by continuous? 1, 2, 3, 4, 5, 6, and so on. Even it can run into the what's it called, negative value, both into the positive end. It has no end. Into the negative, it has no end. The most appropriate analytical regression analysis would be a linear regression under the assumption that there is actually a linear relationship. There is actually a linear relationship. What do I mean by linear relationship? Do we still remember our simultaneous equation, quadratic equation of secondary school days? Let's open the mic and talk now. Dr. Yen, can you help us? When a relationship is linear, what are we trying to say? Marcus, you want to try?
Okay. The relationship is the relationship is there's linear, there's linear equation, there's quadratic equation, there's simultaneous equation. So the relationship is direct between the two sides of the equation. So it is not what do I
Well, relationship between X and Y.
that's the relationship
Okay. Are you seeing what I'm trying to draw on the
second function?
Yes, we are seeing it.
That is one that way wrote on idea. That was the same statement now. Guy, statement
off your mic, please.
Ishaka, please.
You understand?
Ishaka.
So, you understand? So what happened was,
Ishaka, you are disturbing the class.
I think I've muted him. Okay, Ian, your line was actually breaking, but I think you said, I was able to pick a little when there is a direct, a kind of a straight line relationship. Linear, if you can see the, what I roughly draw on the screen. Can we see it?
Yes.
It's a kind of a straight line relationship between the independent variable and the dependent variable. That is the assumption of a linear equation. So what we're saying is, if we assume linearity, that there's direct relationship, there is direct relationship between the independent variables and the dependent variable, and that means your variable has a continuous value. Your variable has continuous value. The most appropriate method would be that you use a linear regression. They use for continuous dependent variable with a linear relationship to independent variable. Example include stock prices, companies' revenue. If linearity is broken and your dependent variable is still, is still having it's having a non-linear relationship, then you might be thinking of using a non-linear regression, such as what they call a polynomial regression or log linear model. So, but basically, what most of our research work revolve around is always around the linear regression or binary regression or ordinal regression. So, if we look at the next one will be the binary variable. When we talk of binary, it's just from the word bi, it means two. That means the nature, what we are discussing here is the nature of the dependent variable. And it is the nature of the dependent variable that will determine the type of regression we are going to run. So if, like I said earlier, your variable, if your dependent variable is continuous and linearity is assumed, you use the linear regression. Now we're talking about binary regression when the nature of your DV, dependent variable, is in a two scalar form, maybe a yes or a no, foreign or local, male or female, independent board or not independent board. If that is the nature of your dependent variable, then the most appropriate method would be to use a to use binary logistic regression used for two-way category dependent variable, e.g. a yes or a no, a success or a failure. Probit is another form of logistic regression. While the binary logistic regression assumes, I think, is the assumption of what's it called, normality that distinguishes between the the binary logistic and the probit logistic. So if normality of a distribution is assumed in the data set, the most appropriate technique will be, and your DV is is binary in nature. The most appropriate method will be to use probit regression. Probit is similar to logistic regression, but assumes a different error term distribution. So that is for binary regression. The third popular one is the ordinal variable. Ordinal logistics regression is appropriate for ordinal dependent variable, which have a clear order, but not having consistent interval. When your DV, a good example would be, maybe you are doing credit rating. Hello? If you are doing credit rating, you know how Augustus and Co. Fetch, Standard and Poor rate organization. Is it that maybe AAA, AA, A+, B+, B-, those kind of rating? If that is the nature of your dependent variable, you might have to consider using what's it called? Ordinal. That's ordinary logistic regression. That is ordinal logistic regression, or you use the ordered probit model. These are the two models you can use when your dependent variable is ordered. Just like I said, we're talking about credit rating for companies. If you're doing anything on credit rating, and you see the AA, you can classify them, or you are running questionnaire that you want to use. What's it called? You want to use, you are using Likert, what they call it, Likert scale. Likert scale to rate. The most appropriate regression method would be to use the ordinal variable. So when we move from ordinal variable to nominal variable. Under nominal, as the word nominal appears, is used to, it's just similar to what's it called? Similar to ordinal, but the difference is that the dependent variable is nominal. And when you say something is nominal, you are just giving it a label. It is not metric. It is not metric in nature. but you are the one that assign label to it. So that is a nominal. Under that situation, you use nominal. Your dependent variable is having a nominal attribute. So the most important thing, regression method will be to use a multinomial logistic regression or conditional logistics regression. So those so I'm trying to move out of this this space. Okay. No, I'm trying to scroll up my documents. Okay, fine. So the next type of variable that's talking in terms of your dependent variable. Like when you want to, the condition that under which you use a Poisson regression is when your outcome, your dependent variable is a rare event. It's a rare event. What are the possible rare events in accounting? What are possible rare events in accounting? Anybody want to help us? Possible rare events in accounting.
In the other room.
Are we together?
Yeah, Dr. Simon, we are together.
Okay. I was asking, what are the possible rare events in accounting?
I think the most notable one is like impairment of assets.
Impairment of asset. I think I absolutely agree with you. If your dependent variable is an impairment of asset, that is not a common. It's not a recurring asset. It's not a
Recurring event.
Recurring event. So the most important model will be to use the what's it called? The Poisson regression model. So we still have the time to event variable. I don't know much about that. We have censored or truncated variable. Still, I don't know much about that. But the most common ones are the ones that we've mentioned. Another most common method is the what's it called? Panel data variable. When your dependent data and your dependent variable is structured in panel form. For example, you have the panel longitudinal data observing same thing over a longer period or over a different class, over different classes, maybe sectorial wise or country wise. You are analyzing the impact on the DV based on sector or segment. Then you have to consider using the fixed effect and random effect model for your analysis. You run the regression either using the fixed effect or random effect. In some paper, you see both random and fixed effect being used as a robust check on the analysis that has been done. So these are just basically what determines the nature of regression analysis to run. So, having said that, I want us to, if you have any question, you can ask. If you have question, you can ask. I want us to maybe dive more into an accounting issue now, using some real accounting data. Accounting, I have data here for Are we there? Hello? Barrister, sit
We are
down.
together.
Okay.
We are together.
Is it? Okay. Who is that? Idris? Idris? Dr. Idris? I need somebody
Good evening, sir.
Okay, good evening. I
Good
need
evening,
somebody.
sir.
Okay, hold on. I need somebody to just be giving me feedback back. Okay, can we see my screen now? What are we seeing?
Yeah, Dr. Simon, we are seeing your screen.
We are seeing
the
it.
data.
We are seeing the data.
Okay, you can see the data. This is the data of the consumer goods sector. Consumer goods sector of the Nigerian Stock Exchange from I think this is from 2013 to 2022. We have dividend per share. We have Tobin Q. We have institutional ownership. We have a turnover. This is the log of turnover. What do we mean by log of turnover?
That's the logarithm of the turnover value for the companies for the year.
Dr. Charles, are you the one?
Yes.
Okay, why do we need to do the log? Why not work directly with the turnover?
No, because the value, the value of these turnovers, they are high values. So it will be difficult for you to put them in regression like that. Not that they cannot go, but it's better you take the log so that it will be easy for you to manipulate.
You ask me, the log, you are very much correct. The value of the turnover is so high. If turnover is in billions of naira, and you want to be placing billions of naira beside the return, ROA, return on assets,
Yes.
which is just a return on assets, who probably will be ranging from maybe minus something to plus 10, 12, 15, 20, or 30 at most, and you're having turnover in billions of naira. So it will make your analysis highly imbalanced. So what you do to normalize the data, you bring it into a manageable level by converting it by converting the turnover to the log, to natural log form. So this turnover of these companies have actually been converted to the natural log form. So, and if you can see the figures, they are not too far away from each other. If dividend is in 0.0 series or 1 point something, Tobin Q is also in, Tobin Q. Dr. Charles, You have an
Yeah.
idea of Tobin. You have an idea of Tobin Q.
Yeah, it's what researchers use to measure market value of companies.
Market value of company. Thank you very much. Which is more like the market value of ordinary share plus the value of debt, plus value of debt divided by what's it called, the total assets or something like that. But we can always get the formula, something like that. So it's a ratio, or it's one of the things researchers use in measuring value of a firm. So we have that, and we have a ratio of institutional ownership. Institutional ownership. We have the turnover, log of turnover, ROA, equity to debt ratio. So now, can somebody from these 5 variables, I want somebody to propose a research topic that fits into this, so that we can run the regression. Okay, Barrister Osita.
Hello.
Barrister, and with you.
My own is not. I'm not trying to answer your question, but I have a concern.
Okay.
These variables here now, how were they generated? How were they calculated to be brought into all these points, 009, all this? How do we, get up to this level?
Very well.
I'm talking of the variables that is
before
us.
I understand you.
Institutional owner, turnover, ROA, equity, debt, all these figures here. How were they gotten?
Okay. Dividend per share, we know how dividend per share is computed. Am I right?
Mm-hmm.
They are accounting ratios. Barrister Osita.
Yes.
You agree with that one?
Yeah.
Your annual report would definitely have declared dividend, total dividend paid. Total dividend paid, or declared dividend rather, total dividend declared, divided by the number of ordinary shares.
Okay.
Will give you dividend per share. Am I right?
Okay.
And Tobin Q was one of the variables I tried to explain earlier, how the formula for Tobin Q, which is market value of ordinary shares. Market value of ordinary shares plus the market value of debt, of total debt, total debt capital, or total debt.
Internet is bad in this house.
Divided by total assets.
Okay, year by year, huh?
Year by year.
Year after, yeah, okay.
So that formula is what you use to get Tobin Q for each of the company for each of the years.
Institutional ownership. Okay.
Institutional ownership is also, that is derivable from the annual report, which is the percentage of over owners.
Yeah.
And that's institutional owner over total share, over total shareholdings, times 100 will give you the percentage of institutional holding.
Okay.
Turnover, I've explained turnover earlier, which is this is log of turnover. What we'll do is what we'll use here is the log of turnover, because turnover as a figure is big. It runs for this company to be running into their billions of naira, and we cannot be using 9 digits Am I right? 9-digit figure against 2 digits. It will make the computation skewed. So the log form is to just compress it, and then they still don't lose their features. They will not lose their features. You just convert the figure into their log form, so that we can make a comparison.
Yes.
Exactly. So ROA is is the most common return on assets, which is net profit over what? Over total capital employed or total assets. Am I right?
Yeah.
And equity to debt ratio. Equity to debt is just equity over debt, which simply measure the cover equity provide for the debt capital. So these are, once you have your equity value from the annual account and the debt value from the annual account, you divide equity by debt to get your equity to debt. You understand? And this, in your research, let's say you are writing a research paper.
Okay.
Off your mic.
Bello.
Bello. Okay.
Dr. Aparaka, mute them.
I think I've done that. Okay, so now can I go back to the question, Barrister Sita?
Go ahead.
Can you formulate a research topic based on this attribute? Let me.
Can we talk about firm performance? Firm performance.
Determinant of firm performance?
Yes, so something like that.
So
corporate governance on firm performance. Effect of corporate governance on firm performance.
Effect of corporate governance. I'm talking based on this attribute too, because corporate governance, how many corporate governance variables do we have here?
The only variable of corporate governance is institutional ownership.
It's only
institutional
ownership.
That's only corporate governance.
It doesn't work. It's the determinants of firm performance.
Okay.
Or characteristics of
determinant of
firm performance.
Firm performance.
Yes.
I would have said determinant. Okay, he has removed that. The thing there is determinant.
I deliberately removed that.
You removed that X and Y, right?
I removed the two S and Y. I don't want to lead you into
the two Y.
Yeah.
So I was thinking we have two dependent variables, two proxies for the dependent variable.
No, I want us don't look at that. That's why I removed it. What I go with a Barrister Osita, determinants of firm's performance.
Determinants of firm performance.
Or we can also do determinants of dividend policy. We can also do the determinants of firm value.
Yeah.
Yes.
You understand? So it depends. Any of these can.
Yeah.
What I'm trying to say is, dividend per share can be.
Let's go with determinants of firm value using Toby's Q as our proxy for the firm value.
For firm value, that's another one. What I'm trying to say, this can be the DV. Dividend per share can be the DV. Tobin Q can be the DV, and what's it called? ROA can be the DV. If you are using ROA for DV, that means we are looking at determinants of firm's value. Am I correct?
Yeah.
So if you are looking at Tobin Q, we're actually looking at determinant of if you are looking at in Q, we are looking at determinants of firm value. If you are looking at ROA, we are looking at determinants of firm performance. Am I correct?
Yeah.
So, is that right?
Yeah, I'm with you.
Okay. And if I look at dividend per share, I'll probably be looking at a determinant of dividend policy. So from these 5 variables, we have at least identified 3 topics that we can run. And I want us to run the 3 regressions simultaneously, like one after the other. Is that okay? Is that okay? So let me see. I'll take this information to starter.
Yes, sir.
Okay, copy. I go to starter. No, I've not shut down my system since yesterday. I'm trying to reopen my starter. Zoom screen sharing. Let me share my starter. Starter. Okay. Can we see my starter screen now? Barrister, can you see my screen? Starter.
Yeah.
Okay.
Yes, sir.
So I've copied the data, and I'm going to import the data into the data editor. Copied, paste. Now, can we see the data in the data editor?
Yeah. Yes, sir.
Okay. So I go back to the starter main window. Now I've imported the data. Can we just if I do a quick shortcut summary statistics, SUM, enter. Can we see the descriptive statistics? What's the number of observation? Let's unmute ourselves and interact now.
160.
160.
Yes.
Okay, all of them. Can somebody tell me why company is showing 0? There is okay, let me highlight it. Can we see it? Company is showing 0. Why is it showing 0? Dr. Charles.
Because company is not a data. Because company is not a data. That's why it's showing.
It's not a variable.
Yeah, Dr. Padaka.
You are right. It's not a variable.
Yeah, it's not a variable.
Okay.
That's why it's showing.
So if I don't want this to occur, I will just type in. I will type in the sum space, go to the variable bar, and pick all my variable one by one. I'll start with what's it called? Dividend per share. I was in it. Next one is to be in Q. Okay, you want me to start with FEM so that we can run when we are running the regression. But let's do ROE first.
Start
as
just
DV.
start with dividend per share. Start with dividend per share.
No, don't worry.
Yeah,
Let's
just
do
start with your
ROA first. I want us to ROA,
Okay.
right? We then take dividend per share, Q, institutional ownership, turnover, equity to debt. So summarize. So this is the summary of the statistics. Are we there?
Yep.
You can see the difference. Company is no
Yeah.
longer appear. So now let's do correlation. Remember, correlation is 0.
Core.
Sorry. CO. I say 0.
Core.
But we have to take it with the we'll pick the variables because there are other non-variable. If I just say core now. Okay. I want to be sure that I didn't pick firm.
You pick firm now.
That's firm to firm.
You pick firm to firm.
You pick firm and
Yes.
company. Did you pick company? No, company is not even, it does not have the attribute of variable. So since firm is not even a variable we are considering, so that's why core. Let's pick the variables we are interested in. Like, can you see my highlights?
Yes.
I just pick those variables since we have defined them up during the summary statistic, copy. Instead of selecting it one by one at the variable panel, I put it there. That's dividend per share, Tobin, institutional ownership, turnover, and what's it called?
The
equity debt ratio. So enter. So this gives us a better, the most appropriate correlation for us. So that's the correlation. So for this now we can run regression for
Dr. Padaka, please, sorry to go into this more. Hello, Dr. Padaka.
I'm with you.
Okay, please, this correlation. If you can just show us how to do that, that you show the significance at 5% using that star. Just show us how to do that, so that at a glance one can see the ones that are significantly correlated.
You are talking about correlation.
Yes.
And we have not reached. We are just about starting correlation.
But not reached there now.
Is this not correlation that I'm seeing? This score.
That's sorry, correlation. You are correlation with star.
Yeah, like to show the significance. You
don't show significance in correlation.
Regression.
No problem.
It's in regression. It's in regression. It's in regression. It show significance.
No, Dr. Padaka. Sorry for watching. Let's just continue.
Okay, so we want to regress dividend per share. So is that dividend per share we wanted? Yes. That means we are looking at what are the determinants of dividend policy. That is the first one we are running now. That's basically what we are doing. We want to know what determines the dividend policy. Is it Tobin Q, institutional ownership, turnover, or equity to debt? So I've said the variables. So with this now I can do enter and see our analysis. So this is the regression. Dr. Bello, you want to interpret this result for us?
From where?
From you now. From the regression analysis, not from the descriptive or correlation, just from the regression. I think we should be comfortable with this correlation and summary statistic by now. Am I right? No, if you are not, this is one we are all on the same level.
I'm here to master it too.
That's the descriptive statistics.
No, the regression. This one you say I should interpret now.
Okay, let me get me. Or what's the implication of this?
Maybe after today.
Okay, let me ask you. Just this one, R square.
Yes.
R square is 0.75.
475.
Yes.
No, 0.47. No.
0.475.
Yes.
What's the implication of that? Of R square being 47, that is 47%. What's the implication? Dr. Charles, you want to help us?
Okay, can I come in?
Yeah, Barrister, please go ahead.
From what we learned yesterday and my little knowledge, the R square, now that is below that 0.47 means 47%.
Very correct.
Which means it's not up to 50. It's not up to 50%. Which means that the IVs, the independent variables, are not able to explain the DVs at a comfortable margin of yeah.
Barrister Sita, hold it there.
Sir. Okay.
Barrister Sita,
okay,
I do not know where you got
sir.
that one from.
No. My understanding is that the R square, as we have here, means 47%. 47%.
Very well. 47%.
Which means that the DVs also are unable to explain the IVs.
No, I disagree with that part. I disagree with that part.
Or that,
47%,
okay.
no doubt. I agree with 47%.
But the variables are not too good. The selected variables are not.
They are
too good.
They are good.
They don't have strong
good.
strength.
They have.
They don't have strong.
No,
they are not strong enough.
Some of them are significant.
They are very strong.
Okay.
They are strong.
Very strong.
Yes.
Okay.
From what we are seeing here now, Tobin Q is significant at 1% level.
No, don't go there. Dr.
No, it's
Charles,
not that one.
we are talking about R square. R square.
Okay, R square.
Yes, the R square is 47.5%.
Good.
And Paristosisa is saying 47.5%, since it's not up to 50%, is not good enough. And I disagree with him.
No, it's good enough. It's good enough now. That 47%, is that 47.5% is saying that this Tobin Q, institutional ownership, turnover, and equity to debt, predicts 47.5% change in dividend per share, which is representing dividend policy.
Absolutely. That is the interpretation. These variables, Tobin Q, institutional ownership, turnover, equity to debt, is able to explain 47.5% of factors or variables that explain the DV. It's only able to explain 47.5% of movement in the value of dividend per share. That means there are other variables unaccounted for in this model. that constitutes about 53% unaccounted for. But this model is accounting for 47.5% of factors that affect the value of dividend per share. Barrister Star.
Okay.
I'm with you.
Is it clearer now?
Yeah, I'm with you.
Excuse, can I ask a question?
Yes, Dr. Bello.
It means all those variables have only 47.5% influence on DV.
Exactly. But do not emphasize the only, because why I'm saying this.
Okay.
When you do your research, if you see 35%, 30%, don't panic.
Yes.
There are papers that I've seen that is even doing 20%.
What is the standard?
Good.
The standard, I do not know of the standard, but obviously you will not run a regression that will give you 5%. and come and say that your variable is only able to explain 5%. Go and look for more variables now.
So no benchmark. No benchmark. No benchmark.
See, Dr. Polaka, let me chip, if I can chip this in, please. Dr. Farouk, when he was doing this thing for us, revision on seminar in accounting,
yes,
he said that for R square, if you get anything between 25% and 70%, you are good to go. And then for adjusted R square, between 20% and 50%, you are okay.
You are good to go.
You are good to
go.
That was what he told us then. I remember, I even jotted it down. So because it was like, if it is too low, it's as if you have not done anything.
Exactly.
Because if it is too, and then if it is too high also, it will now be suspicious, because it will now be as if you are saying, okay, it's only these variables you have considered that is affecting this dependent variable, which might not be in reality.
Let me also add, when it becomes too high, 90%, 95%, suspect the variable, then might most likely to be issue of multicollinearity or heterocadasticity.
Yes.
Because of more of a multicollinearity is becoming, the variable are getting too linearly related to the DV, and that is what is. There's that the independent variable.
The multicollinearity is in between the independent variables themselves. That means they are even closely affecting themselves.
They are closely affecting themselves. That's what I wanted to say. They are closely affecting themselves. So that is what is giving rise, or that might be what is giving rise to high value of the R square. Okay, I think that is very important for us to grab.
Okay.
Yes.
So for the purpose of our
Dr. Simon.
Yes, please.
I want to be very, very clear on this R square now so that I can put it in my brain.
Okay.
From what I have heard now, R square value is explaining the percentage of influence of IVs on DV. Am I correct?
Yes. That is the IVs that you have chosen for this model.
Yes.
Oh, who's knocking on my door? Sorry, let me just attend. I'm not expecting a guest. 1 minute. I said somebody's knocking at my door.
In the other room?
No, no, hotel. I go for hotel. 1 minute, please.
Dr. Bello.
Who is that?
Dr. Bello.
What?
Yes. Yes, Dr. Shas. You were missing the action yesterday.
Yes,
he's doing honeymoon now. Why do you always like to disturb somebody? Somebody on honeymoon, you are disturbing him.
Who is on honeymoon? Dr. Charles?
Why the young man to enjoy himself?
Is it Dr. Charles that is on honeymoon?
He has the license. No worry.
After 1 month, which kind of honeymoon you want
It's
to
still
do?
the laugh. You see,
Okay.
You say until the well stop being dry.
oh, dry well.
So I'll keep drilling. I'll keep drilling until the successful well.
You know that now. You're pretending.
So carry go. You are licensed.
Yes, sir.
Hello, class.
Okay.
Thank you, Dr. Simon.
Yes.
Hello, Jamil. Welcome.
Well done, Governor.
Thank you.
How's your day?
Fine.
Thank you for this group presentation. I salute Dr. Simon.
Thank you, Dr. Ibrahim. Am I right?
Yes, you're right. Thank you very much.
Okay, thank you.
Thank you.
Okay. Dr. Bello, Rahman. Yes, I think we were trying to clarify something.
Yes, the R-square value is explaining the percentage of influence of IVs on the DV.
That's correct.
Okay, thank you.
Okay. And the adjusted R square is just, let me call it a stricter version of R square, just filtering out some possible error under a tighter condition. So, and that is why the most often adjusted R square gets less than the R square.
Okay.
So, what else does it needed to explain in that? Normally, all these other statistics are more of this what we call the F score.
F statistics.
The F statistics. I do not think I have much explanation on that myself, but I focus mainly on what is vital for research. I mean, what I see in research papers as the basis of what I'm trying to explore, so that I can ask myself or interpret the results that is before me.
Okay,
one more question. One more question, please.
Just okay. I want to ask also a question.
One more question, sir. This root MSE, what does it stand for?
The
last item at the bottom.
That is what is called the mean square error. I think that is called mean square error. I think that's okay. The meaning. We can do a quick Google search on it, but I think that's just the full meaning.
Also, a follow-up to that question too. Yesterday, this probability which is greater than F. Yesterday there were some values, and today's on there is no value. What actually could one explain as a reason for this?
Okay.
There are values. Probability.
It's 0.00 now.
V square.
Do we get to that?
Yeah, the probability F now, which is 0.000.
P value.
What is represented?
I mean, what does it
what it signifies? Dr. Simon, please, can I come in?
Yeah, please do.
Okay. So that probability greater than F is showing the significance of the F statistics. That is what it's showing. That F statistics that you are seeing there, that is a F in bracket 4155. That F statistics, what it shows you is the fitness of the model of your regression. That is what it shows. You know, you formed a model that you are now using to run this regression. So that is what that F statistics is showing you. And normally, statistically, this F statistics, if it is positive and is greater than 2, that means the model you are using to run this regression is fit for the study. But if it is less than 2 and it is negative, that means your model is not fit. And that is where your probability F, your probability greater than F will not be significant. In this case now, you are seeing 0.000 is significant, meaning that the model, this model we are using to run this regression is fit for this study. That is what it is showing. Assuming this figure that we are seeing, this 35.09, is less than 2 or even negative, you will have seen this.
Can we hear him? Hello, Dr. Charles. Dr. Charles, we lost you.
Okay, sorry. Maybe it's my internet. Can you hear me now?
Yeah.
Yes.
Yes. Start again.
Okay. I was saying that this probability greater than F that you are seeing, that is significant, is showing that the model we've used to run this regression is fit for the study.
Absolutely, I agree with you.
And that is why we are seeing this F number here, 35.09. And I said that if that number is less than 2 or even in the negative, this probability greater than F the value will not be significant. It will be higher than this. And it's telling you that the model you have formulated to use and run this regression is not fit for this study. But in this case now, thank God, it's
the model,
and we are seeing it. That is why it's showing here. The greater this value, the greater this F value, the more significant this probability greater than F will be. And it's showing you that your study model that you have used for this study is fit for the study.
Yes.
So wherever you do a study, then you see that this value is not significant, and this your F value here is in the negative, then you know that the model you are using to run this regression is not fit for the study, and that is even going to fault everything that you're doing. So that is that one. Then for this R squared and adjusted R squared that Dr. Simon has already talked about, what is just the difference between R squared and adjusted R squared is that adjusted R squared is like they call it coefficient of alienation. It is taking note that your error term in your model. You know, after you specify your model at the end, you put error term. That error term is what this adjusted R squared is taking consideration of, and that is why you always see it lower than the R squared, because it takes consideration of that error term that is in your model, and that's why they call it coefficient of alienation. While the R squared, they call it coefficient of determination. So once you run regression, the first 3 things you want to look at here, all these things that are here, what you are interested in is your R squared, adjusted R squared, and then this your probability F value, whether it is significant. Those 3 things are the main things you need. Then after that, you now start looking at your p-values, whether which of your independent variables are significant, then the direction, whether positive or negative. So that's it.
Dr. Charles, thank you very much. I think
it's like sorry, it's like you repeat this, you know. He's made a point. He has made a very fine point that
he has made a very good.
There are 3. Yes,
go ahead, sir.
I'm saying that I would have liked Charles to repeat what he said. He said there are 3 areas to look at: the R squared,
the F statistics,
the F statistics, and one other one just said that these are the main areas for you to interpret.
F statistics.
And you know our problem. Yes.
R squared. Adjusted R squared.
Yes. Explain each for us, please. Don't be annoyed.
Dr. Charles, can you take that again?
F statistics, please do. Then after I go to the next one, please, with the plead.
No, I know I still see. So Dr. Simon have already explained the R squared and the adjusted R squared. So I was just trying to make a point of this F statistics, and I said that this F statistics is important because what it tells you is about the fitness of your model that you have used to run this regression. You know, in our chapter 3 now, you are going to raise a model. Either maybe you adopt from someone or you formulate based on the literature review you've done of other studies. So that's your model now that you said this your DV is equal to so IVs. That model, how you know whether that model is fit for this regression that you're running for your study is this F statistics that will show you. That's this probability greater than F.
Yeah.
I said when it is significant like this, like we're seeing in this case, what it shows is that the model that we use for this study now, which in this case is DPS equal to Tobin's Q plus institutional ownership plus turnover plus equity to debt, is fit for this study. That means our model is not faulty. It's good to go. And I said how you know is that this other figure on top of it, which is that F value that you're seeing 35.09, that if it is higher than 2, then you are going to see that this your probability greater than F will be significant.
Oh, hello.
Yes.
Wow.
Hello, Dr. Shah.
Yes?
I don't know, something is seizing your phone. So some of the wordings I can't hear.
That's the problem.
Forgive me, please. Where I am, my network is not good. Sorry, I beg.
Can you slightly change your position?
No be Abuja Day. No,
Go
this
to the
place
sitting room now.
I don't position myself. This is where the network is best too.
Okay.
If I shift now, the network self, I feel not even get connection.
But I'm hearing him clearly from my own end.
Why not? He's in Madam.
Sorry, please. I just position myself so that I can get network here.
Okay, let's go. It's better now. F statistics.
Okay. So in summary, let me just summarize it here. F statistics. I say F statistics tests the fitness of your model for your study. That's what F statistics does. And that is this probability greater than F. Someone asked that, what is this probability greater than F? Someone was asking. That was what even brought this whole talk. And I said, it is your F statistics. And what it does is that it tests the fitness of your model for the study. So when it is significant, that means your model that you're using for your study is fit for that study. But if it is not, then that means the model that you have formulated for the study is not fit for the regression that you're running. And I say how you will know is that this figure on top of it, that's the F value that's on top of the probability greater than F. If it is less than 2, that's 2 as a whole number, and that's going to your negative. Yeah, no, this 35.09. This one up here, 35, that 35.09, yes.
Yes.
If it is less than 2, that's 2 as a whole number. If it is less than it and starts going into negative, you will find out that this your probability greater than F will no longer be significant. That's this value will be higher. That's as this one up is going lower, this one down will be going higher. And that is telling you that your model, if like I say, if it is less than 2 and going into negative, that means your model you're using is not fit. But in this case now, once it's more than 2 and it's going up, in this case we have 35.09, and then you see this your probability greater than F will be coming down. And that is where you know that, okay, yes, your model is fit. So once you look at your regression, once you run regression like this, your result just come out. The next thing you just go and look at your F statistics. Okay, my F value is greater than 2. My probability greater than F is significant. That means this model is fit. Then the next thing, you look at your R square. Okay, what is it? It's not too low, it's not too high. I'm good to go. Adjusted R square in the same region too. And the next thing you now start looking at is your p-values for your each of your independent variables. Which one is significant? Which one is not significant? And then you now start looking at the t-values to know the direction of the coefficient, whether it's positive or negative. So Dr. Simon will show us that one, but I just wanted to draw our attention to this F statistics, what it means and why it is important. And why, once you run your regression, you look at your F statistics, your R square, and your adjusted R square. So
very well said. Dr. Charles, thank you very much. So I think we have a clearer picture of F statistics. F statistics, R square, adjusted R square. And the last one there is the
coefficient.
Root mean square error. That's the root mean square error, which is It measures the standard deviation of the residue, and it indicates the average distance of the observed value from the regression line. So is that E in the error terms in the model? That is what the roots, that's, if you draw your regression, model, you always have the error time. That's the, what's epsilon, or what's it called, that Greek word? Epsilon. I think we are familiar with that. I think that's what this root MSE refers to. I think Dr. Bello asked what is that MSE the other time. So that said, I think we can go back into our model again. What other interpretation?
Network.
Okay. You have not lost much, Barrister Sita. I'm just trying to recap what we have done. The four items there. That's the F statistics, the probability value of the F statistics, the R square, adjusted R square, and down to the root MSE, that the mean square error. So the next most important thing there. Are we together? I hope. The next most important thing there for this is your coefficient and the p-value. The coefficients and the p-value. So how do we know which of these variable is statistically significant? And the significance, is it positive or is it negative? Like I said yesterday, the coefficient shows the impact of the IV on the DV for each unit movement in Tobin Q, for instance. It will impact on a dependent variable at 3.8, at a multiple of 3.8 for each unit movement in Tobin. And for each unit movement in institutional ownership, just watch my highlight so that we are on the same page. For each movement in institutional ownership, it will impact negatively, because that is a minor sign. It will impact negatively on the dependent variable at 0.02. For log of turnover, the impact is positive. And for each unit movement in the log of turnover, that's the turnover, it will impact at 1.566 multiple on the dependent variable. And for equity depth ratio, the impact is positive, but for each unit movement in equity, it will result in a 0.219 movement in dividend per share. That is explaining the coefficient. This coefficient, if you have done your regression model before, if you have done a regression model before, you have your beta loss. Are you seeing what I'm trying to do?
Yes.
Yes.
Beta, let's call this beta 1 by x1 loss beta 2 by x2. and so on, before you have the error term. Am I right? That's y equals to, this is, I'm trying to explain this, the model for this relationship. Dr. Charles, is that correct? Hello? No feedback. Are we together?
Yeah, we are with you. We are with you.
So this beta that you are seeing in this model,
yeah,
this B0, B1, B1, B2, B3 is the coefficient where this B is representing coefficients. And that coefficient value is here. Are you getting it now?
Yeah.
That's it. When you have the coefficient value, this is the coefficient value. So what we are now saying is for Tobin, what's the coefficient for Tobin?
3.0, 3.20.
No, 3.80 now. 3.8.
3.8.
3.80.
8
or 3.8, yeah.
Times
plus
3.805.
3.8 times x1 is what we are saying there for x1. 3.8 for, sorry, you know, it's mouse I'm using to do this, so I'm not you now say I'm just trying to be creative.
It's working, we're seeing it.
Yeah. So this the other one will be B2. B2 will be minus
0.02.
0.02 times
x2
x2 plus and so on to
and so on and so forth.
So that is what I'm trying to do is the explanation of the coefficient. We are saying that for 1 unit, x1 now is a 1 unit of x1. You will need, the impact will be 3.8 times x1 on the value of on the value of what's it called, dividend per share. So x1 is having the highest coefficient. That highest coefficient means it's having the highest impact on the value of a dividend per share. Is that clear?
Yes.
And which one is having the lowest impact? Maybe in the negative now, minus 0.2. Or is anyone lower than that? No, we have minus, okay, no.
Minus 1.5.
It's minus 0.02 or so is the lowest.
Yes. Only institutional ownership that is negative, that has a negative effect.
Only institutional ownership.
How about the last item there?
No, that one is constant.
It's just a constant.
That minus 1.5.
Yes, that minus 1.5 represents
constant.
Represent this. That is
the constant in your model.
If B1, x1, x2, x3, they are all is 0. What is left is your constant. That is minus what's it called? Minus 15.23. That's your constant. That's the what's it called? Beta 0. Beta 0, that's the constant. Beta 0 represents the constant. In absence of every other variable, what would be your model? That is the minimum value for your y is going to be minus 15. That is, we are talking, but again, that is not it's not a point of focus for any research that I know.
No, it's just learning purpose, for learning purpose.
No, I'm also, no, I think I've tried to explain it, but I'm just trying to say that it's also not your focus. Just having an idea of it is fine. So that is the constant, the coefficient, but we cannot take our conclusion based on coefficient alone. We have to now check for the significance. All the variables are positive except institutional ownership. That means institutional ownership is having a negative impact, and that's what it means. So, but since we have the coefficient, but are they significant? Will then be the next question. To answer the question whether they are significant, that's where we now come to the
p-value.
The p-value. The p-value. We are running the test as what's it called? 5%. What they call the degree of freedom?
5% level of significance.
5% level of significance, rather. So anything less than 5% is significant. If your P is less than 5%, is significant. So Tobin is significant, highly significant.
Highly significant.
Turnover. Institutional ownership is not significant.
It's not significant.
Turnover is significant at 5% too.
Yes.
Equity to debt is not significant.
It's not significant.
At 5%.
5%, yes. At 10% it is, but it's not advisable to go for that 10%.
We don't work with 10%. Like I was saying yesterday, even pure science uses 1% level.
1%.
So, and to further explain this, we also, if like Tobin, in the explanation, it will be very much important to emphasize that Tobin is positive and is significant at 1%. Even though your threshold is 5%, the emphasis now is that even at 1% is highly significant. Because it's less. Tobin, the p-value for Tobin is less than 1%.
It's 0 now.
But it's less than 1%.
It has no value. 0 means no value.
It has value. The value is 0.000, which is less than 0.01.
Wow, okay.
No,
but
I
don't know if I can. Anyway, just go ahead. I don't know.
No, Dr. Charles, you can add lend your voice. Lend your voice.
Okay. But it's not see. There is 0.00 that you are seeing for this Tobin Q under the p-value.
Yes.
Just like I was telling you in that F statistics, that place you have probability greater than F that you saw 0.000. You get, but Dr. Simon is putting his cursor there. What is that? What is it telling you? What is telling you is that this figure now, this 0.00 is significant at 1% level. That means if you check this 0.00, that means it's telling you it's 100% too. So what this 0 point, you get 100%, yes.
Absolutely.
So what is telling you now is that this Tobin Q that you are seeing here determines greatly what is significantly affecting the dividend policy that's in this case now measured by dividend per share of a company. So is a big factor that influences dividend per share. That is what this result is telling you, that is 0.000. And if you look at it, what is Tobin's Q? Initially, when we started this conversation, we said that it's testing market value. The formula for Tobin's Q normally that is used in research generally is market value over total assets. So if you look at it, the market value of a company, which is where in the stock market, that's where you normally get it, it determines the dividend per share of that company. So that is what is telling you that is a significant variable in determining dividend per share. That is what this 0.00 is telling you. So it is significant at 100. In fact, it is this 0.00 means that it is very, very significant. They say it's significant at 1%.
Highly significant. Highly significant.
Yes, because it's less than 0.001. Okay. So that's why it's like that. Then if you look at the next one now, institutional ownership 0.4 is not significant because it's more than 0.05, which is the threshold we are using for accounting research. Then turnover 0.03.
Dr. Charles, I don't think 0.4546 is more than 5%.
0.46.
That is 46% you are
That's
saying there.
46%. Oh.
That's 46%.
0.46%. Yes.
Okay. All right.
So interpret that one now. Interpret it.
Okay, this one now.
Insignificant.
Okay. Huh? If I want to interpret this institutional ownership number, I would say that the regression from the analysis done, from the regression analysis done, found that institutional ownership does not have a significant effect on dividend policy of firms measured by dividend per share. Though it shows a negative relationship, but this negative relationship is not, yes, it's insignificant. Therefore, it is not a determinant of dividend policy.
Exactly.
Chicken. Then I'll say this result is in line with so, and is not in line with the result of so. Therefore, I will accept the hypothesis. Therefore, this study accepts the hypothesis that institutional ownership does not significantly affect dividend policy of firms. Full stop.
You are accepting the null hypothesis.
Accepting the null hypothesis. That is what this result is showing. This institutional ownership that is saying 0.46.
But in the case of Tobin Q, the null will be rejected and the alternate will be accepted because your null is most likely to be that Tobin Q does not impact or does not affect the dividend policy of a firm. Now, for Tobin, the null hypothesis is rejected, and the alternate is accepted. Am I right?
Yeah, correct. Correct.
So that's the interpretation, and the same thing goes for equity to debt. Are we all following? If going by the voices that are interacting, I can say Dr. Bello, Varistosita, Dr. Charles. I'm not hearing others.
Dr. Yi said something just now.
Okay, the governor.
She's busy.
He's busy.
User busy. User busy.
Okay.
User is not. User there. Yeah.
Governor, let's hear your voice now. Let's hear your thoughts. Are we together?
I've spoken before now. So what it doesn't mean that when it's positive and significant, because this 0.000 is significant at 1%, right?
Yes.
Yeah. Yes.
So does it mean when the positive and significant, you reject the null?
Positive and significant, you reject the null.
And accept it.
Because your null is already in the negative.
Okay.
Your null is in the
Okay, yes. It's true.
Your null is in the negative.
Yes, null is already in the negative. So when it's positive and significant, you reject.
Yes, you reject the null as accept your alternate.
Okay, Dr. Yi, let me say something. This your regression result, this your p-values, that is what is going to tell you whether you will reject your hypothesis or you will accept it. That coefficient is only showing you the direction of relationship between them. See what I'm saying? For like this institutional ownership now, the coefficient is minus 0.02. What it is telling you is that, as it is minus, is that as dividend per share is going up, institutional ownership is going down. As dividend per share is coming down, institutional ownership is going up. They have opposite direction. But for Tobin Q, that is positive now. That means as dividend per share is going up, Tobin's Q2 is going up. That is what that coefficient is telling you. What will determine whether you accept your hypothesis or not is this p-value that you are seeing. You get? So once you look for this first one now, Tobin Q is significant, and you have stated your hypothesis in the negative form, that's the null form, saying that it is not significant. So as I'm seeing that my p-value now for Tobin Q is significant, that means I'm rejecting that hypothesis. Then for institutional ownership, that I've seen that the p-value is not significant, and I've stated it that does not significantly affect, I will accept that hypothesis. For institutional ownership, you will reject the hypothesis because what? It is significant. Then for equity to debt, you will accept your hypothesis. You get? This is your coefficient, this is your direction. The only place you are stating it is in your interpretation of results, so that you will show your reader how that's your variable that is significant, how it is affecting that dependent variable, so that they will just know that, okay, this is the direction, both of them are going the same direction, you get, or they are going opposite direction. That's all. And that's why some research will tell you that once your variable is not even significant, there is no need talking about the coefficient, because it's not, whatever the coefficient is, it's not going to happen.
It does not matter again.
It does not matter again, since it's not significantly affecting it. You get? So there's no need again. So is this your p-values? That's why I say once regression results come out, the first thing I'll look, F statistics. After F statistics, R square. I don't even bother about adjusted R square. Once I see F statistics and R square, I'll just come and look at my p-values. Once I see my p-values and see that, okay, these are the ones that are significant, these are not shit, you know. All these under plenty figures is just serere for statistics. That is the thing that are important.
What in serere? A formula.
Can I make a request?
Serere.
Hello?
Hello, yeah, Dr. Bello.
Request. Dr. Shas. Yes, sir.
Yes.
Dr. Shas.
Yeah, Dr. Bello.
Please, can you go to chat and just give us a small note, summary of what you are saying on F statistics, please?
Okay.
Okay, that'll be fine.
Thank you.
Okay, sorry, I have a question, Prof.
Where's the prof?
See, because you're teaching us, you are the prof. So don't be agitated.
Professor Simon.
You have been
Prof. Simon.
You have been dashing us, doctor here. So in like manner, I want to ask a question. In formulating your hypothesis,
Barrister, who is taking your voice?
Yeah. Hello?
Your voice is freezing.
No, but I'm here now. I'm here.
Hey, we can't hear you. Your line was breaking.
Okay, are you okay now, sir?
Better now.
Okay. Please, I want to know, in formulating your hypothesis.
Yes.
When do you say this factor affects and this factor does not affect? What guides you in formulating the null and the alternate hypothesis? We are normally encouraged to use the null hypothesis. Are you getting me?
Yes.
But sometimes when you look at it, it will be flowing, does not. At the time, you know, here, affect, does affect.
That is inconsistent. Sorry, I'm jumping. I say that will be inconsistent when you are stating no. You don't come in the affirmative again. of saying it does affect. If you are going to state your no, it has to be in the negative. Does not, does not. It's not, not. And that is why they are null hypothesis.
Okay.
Dividend, Tobin Q does not affect dividend policy. It's a null hypothesis. Institutional ownership does not affect dividend policy. That's the null hypothesis 2. Turnover does not affect dividend policy. Null hypothesis 3. Equity to debt ratio does not affect dividend policy. Null hypothesis 4. So on that premise, you now know you can then be either accepting your no or rejecting it. If it's positive here, it's positive and significant. That means null will be what? Rejected. Alternate will be accepted. Meaning that to be Q have effect on dividend policy.
Okay, good. I'm with you.
Does that make sense?
I'm getting it. Yes.
So for institutional ownership, it is insignificant. It is insignificant. So what's it called? The null will be what? Accepted. Am I right? Because truly, institutional ownership does not affect dividend policy. That's what he's saying, because the p-value is not within the bandwidth. So based on p-value, we reject, even though it's negative. But nobody cares about whether positive or negative again. But it's normally just negative and insignificant. So turnover.
So excuse me, sir. Yes. So the focus
is basically on significant, insignificant. But
so whether it's positive or negative, once it's insignificant, is the null is rejected or be accepted. Which one?
Now you have thrown me into confusion.
No, wait. Once it's significant.
Once it's significant.
Once it's significant, you reject, right?
Once it's significant,
yes.
You reject the null.
The null. Okay, doesn't matter if the coefficient is positive or negative. It doesn't matter again.
It doesn't matter. Coefficient is not a deterministic factor there. It is the coefficient is just telling you the direction.
No particular confusion here. Is it?
The deterministic factor is the p-value.
Okay.
P-value is the deterministic. What this is it?
Network.
It's okay, sir. Thank you, sir.
Your p-value is 1 house.
Dr. Baraka, please mute some people. They are
Marcute.
Okay, it's fine. I've muted him.
Yes.
Okay. Your p-value is the determining factor on to accept or reject. If p-value is I didn't plug my laptop. If a p value is significant, then null is going to be rejected. If it's insignificant, null will be accepted. and that we have tested with the hypothesis that we have stated. Because the null hypothesis for Tobin is that Tobin Q does not affect dividend policy, but the result shows that Tobin Q is what is significant and it is positive, which makes the null invalid. We accept the alternate. Am I correct? The same, for institutional ownership, the p-value is insignificant. If the null hypothesis were institutional ownership does not significantly affect, I think that's the right word I'm trying to find. Institutional ownership does not significantly affect dividend policy. Okay, mark the word significant. Does not significantly. That's the right way to state your hypothesis. So in your hypothesis, you are already signifying that what you are testing is the significance level. Tobin Q does not significantly affect dividend policy. That's your null hypothesis one. Institutional ownership does not significantly affect dividend policy. That's null two. Turnover does not significantly affect dividend policy. That's null three. Equity debt ratio does not significantly affect turnover. Mark the word turnover. The word significance there. So the point of emphasis still remain on that p-value. That's the connection. So if it is significant, you have to reject the null. If it's insignificant, you accept the null. Chicken. I think I rest the case there. Any question or contribution? Any question or contribution? We are running out of time. Can we still continue? I wanted us to run the two other regressions, just turning it all around. Can we do it?
Sorry.
I
want to plead there. Yeah, is there any way we could sustain this our program beyond these 2 days? Whatever it could take us. We can put it maybe on weekends, just as you are talking. Maybe Sunday evenings. Gentlemen, we need to do this. And if there's any how we can contribute towards the what do they call it? The data for our colleague, we will do that. We need to do this so that we can really come out of this. I can tell you that for the 1 year we are there, taking notes, copying every day. What I have learned between last week and now, I didn't get it all this year, even though they were taught, but we're not getting it. But now we're doing both the practical. As he's talking, our systems, they are here with us. And as soon as he finishes, we'll go to the system. By next week, if we are continuing, if you have any issue with your system or with your computation, you ask questions. From there, I think we can, not only passing this exam, we can be experts in this area. Because I'm getting interested in this business. It's very important. It's my thought.
Barrister Osita, thank you very much. Thank you very much for sharing your thoughts.
And some of us are in serious support of what Barrister Osita is saying.
Governor will be moderating on that. I do not have a
God bless you. Thank you.
Yes or
Please.
No.
Consider it done.
That would be great.
So far, Osita is deputy.
But I'm all ears. The only thing, maybe, yes, once we schedule it, it might not just be maybe back-to-back Saturday, Sunday, because I'm actually not in the country.
Yeah.
So even if you want this lecture tomorrow, I can do it. Because I'm not at duty post. You understand what I'm saying? I'm not at duty post.
Oh, that makes it easier then.
That's what is what is making it easy for me this period. But once I'm back during the week, to your tent, O Israel.
Okay, do we reschedule tomorrow now?
Supported.
Fine. Tomorrow is fine by me.
Yeah.
Yes, please, tomorrow, so that we can get the best out of him before he comes back and he will not be available.
And let all of us go home and practice this. So when we practice it, any issue, anything we don't understand, we'll come back here and share it. By sharing such knowledge, some of us will also learn. Please.
Yes, and I will also plead that the recorded this should be sent, so that some of us are following the recorded edition of yesterday. So if they can send this one, to be actually good, so that by the time we are meeting tomorrow, we might have studied the recorded lecture.
I hope I even click record on this session.
Yes, it's recording. You did.
Okay, fine.
Yes, recording.
Okay. Before we go, let's just do a snippet of those regression. We'll continue from there tomorrow, but I want us to just quickly run those two other options.
Okay.
Without explanation.
Great.
So for this one, we did dividend policy. So let's turn it around to take what's it called? Which one are we taking? Determinant of
anyone you want.
Determinants of Tobin Q. Or no, ROA. Let's go for ROA. That's determinants of firm performance. Is that correct?
Yeah. Yes.
Governor, you are the one that proposed that now.
No, it was Barrister CEO.
Okay, Barrister Osita.
Now supported.
Okay. Is ROA here? Dividend per share to be Q, institutional turnover equity. Do we have ROA as a variable? Yeah, we do. So where did I get this one? Why was it not in that place? Did I miss it? Are you seeing what I'm seeing? Are you seeing what I'm saying?
Yes, we are together.
It's like we didn't consider ROA in our first
only
regression.
Four variables.
Yes, we did not.
We did not.
We lost it.
That was a great oversight.
I thought it was on purpose now.
No, it was not. I wanted to run it together.
There were 5 variables and we considered 4.
4. That was an error.
It was on purpose.
No. Dividend per share, Tobin Q, institutional ownership, turnover.
Hey, there's no problem now. It's just to include it now. And please just copy that regression command earlier, then include ROA to it.
That's what I've just done. Dividend per share, Tobin, 1, 2, 3, 4.
I need to look for posting, go back up there.
Which one did I miss again? Why is Tobin not coming up?
You didn't include turnover.
My network.
Turnover, okay.
Yes.
Turnover, thank you. Okay, all of them included now. Interestingly, R square came down to 48. R square came down to 48. I think, what was it before? 40. Oh, it went up. Okay. R square was okay, 47. 47 before, now is 48%.
48.
And turnover is also what's the significance level for turnover? Oh no, what's the significance level for ROA that we didn't include? ROA. ROA in this model is insignificant. Am I right?
Is it because of the minus?
It's at about 15%. It's 0.15 for the P and for the P value. 0.15 for the P value makes it insignificant. Look at it. ROA.
Okay, 0.15. What's the meaning now?
No, who is confused? I only brought in the ROA.
Yes, interpret it, that P value. Interpret it for me.
It's
0.152.
What is 0.152 in percentage term?
15%.
15%. And
So
we are working. It's higher than 5%. It's higher than 5%.
Okay.
So that makes it insignificant.
Okay.
So the null will be accepted automatically because it's insignificant. That means ROA does not significantly affect dividend policy. Okay, so I think that concludes that. But if you want to run the regression for firm performance, ROA should be the one to come forward first. ROA against I'm just changing the order of the variables now. Now we want to regress ROA. Are you seeing my ROA as the dependent variable? And the other four variables becomes the independent variable.
The other one is LO.
Are we together? I'm running the regression now. This is the regression for, what's it called? Determinant of firm performance. Because we are using ROA as a measure of performance. ROA as a measure of performance. The R square in this relationship is 46%. Your F statistics is greater than 2. Thank you, Dr. Charles. And is significant. That means the model is well fitted for our analysis. Your overall fitness of the model is demonstrated in the F statistics. Dr. Charles, am I correct?
He just left. He's not in the house again.
Okay. So our R square is still good enough at 46%. And so also is our adjusted R square. But let's look at the significance level now. Significance level for each of them. That's the P value. And the coefficient. So from the 5 variable, Tobin Q, institutional ownership, dividend per share, equity to debt, turnover, who can tell us which of the 5 variables, the IVs, which of them are significant? Which of them are significant? Quickly, we are out of time. Which of them are significant? Somebody can go.
Tobin Q.
Tobin Q is significant. Which one is also significant?
Institutional ownership.
Institutional ownership. Which one again?
Equity to debt.
Equity to debt. Which one again?
Turnover.
So it is only dividend per share that is insignificant. So, and all the four that are significant, they are significant at a 1% level. True or false? True. Because you have 0, 0, 0, 0, 0, and you have 0, 0, 1, 0, 0, 1. So they are all significant at 1% level. This is the, I would say this is highly significant. We can say now that Tobin Q is positive and highly significant determinant of firm performance. That's one. Institutional ownership is negative and highly significant. Is negative and highly significant. Yeah. Because the p-value is at 1%. It's at 1%. It's at 1%.
Okay.
Dividend per share is insignificant. Equity to debt is negative and highly significant. Turnover. So turnover.
Excuse me. Hello, sorry. How do you interpret dividend?
How do I interpret?
How do you interpret dividend per share?
It's insignificant because the p-value is at 15%.
Yes.
It's just insignificant, dismisses it. Yeah, what you're saying is immaterial. Okay. It's immaterial. So whether positive or negative, it does not matter again. It only matters when it matters.
Okay.
So if it's significant, you now look at it. Is it positive or negative?
Negative.
You understand? So it is a waste of pen or words to be saying that it is positive and insignificant. Yes, we can.
Okay, does it mean that we have to look at the hello?
Yes, I'm with you.
Does it mean we have to look at the p-value first before we go to the
yes
correlation? Exactly.
Okay. I get it now.
So
it will still confuse you again. That's how the thing behaves. That's how the thing behaves, so I'm telling you.
But don't say, allow our deputy CEO. Now that he has gotten this thing, let it sink in.
No, but the thing will sleep again. The thing happens to me like that also. Problem.
But no problem. Repetition strengthens memory, they say. The more we practice, the better it becomes part of us. Okay.
They are correct.
Yeah. I think, can we run the third regression? We are done with this. The third one is supposed to be, what's it? We have done Tobin, we have done ROA. Oh, dividend policy should be the next one. What we are saying with that is that what are the determinants? The determinant of a dividend policy. Determinants of dividend policy. Gentlemen, let me announce to you that this particular data set, I've used it to run write a paper and I've received approval to publish the paper ending of this month. So
congratulations.
Congratulations.
Thank you very much. Guess by
Congratulations, Dr. Padaka. Let me also use this opportunity to tell you that I'll be coming to beg you for data since I see that you are working on consumer goods firms. That is my domain.
So
we
already
have a deal. So
hear you. Yes, we didn't hear the announcement.
Yeah, we didn't get the announcement from Akpadaka very well. Say he has gotten how much?
No money.
You like talking money?
No money.
Use this particular.
I said I've used this particular data to publish a paper, and that paper has been approved.
Okay, that's good.
For publication end of this month.
So you are now using us to practice it.
The paper has already been approved.
I know, yes, now you are now going to the practical.
Please tell us your own announcement.
Thank you, Akpagada. You are too much.
Thank you very much.
Too much, my brother. Leave Charles. Charles is still hallucinating. He's coming from honeymoon. Leave him.
Dr. Charles, want to hear your own?
Dr. Charles was saying something. Okay,
he's talking about his honeymoon, right?
He said he needed data. Okay, let's run the last regression, which is supposed to be
wow,
dividend per share as the dependent variable. So that means I'll knock it out from the IVs. So we are regressing dividend per share, ROA, IV, Tobin, institutional ownership, equity, and turnover. The 5 variables are complete. So regress. Yeah. That's the regression for the determinant of
dividend per share.
Dividend policy. Dividend policy. Dividend per share is just is the proxy used to study dividend policy in this study. Now, you understand? That's another technicality that we need to be sure when we are explaining things. ROA is a proxy for measurement of firm performance, because there are other there are other proxies for measuring performance. You can use ROE. You can use what's it called? Profit margin, gross profit margins. Those are measurement of performance. They are proxies for measurement of performance. You only chose one out of those proxies. So for dividend policy, dividend per share is one of the proxies. You can have a dividend payout ratio. That's another proxy for dividend policy. Or you can have a dividend yield. That is another proxy. So what we are testing is dividend, the impact or the determinant of dividend policy. But we are using dividend per share as a proxy for dividend policy. The other one, we tested firm performance. We use ROA as a proxy for firm performance. The first one was what did we look at? What was that? Was it Tobin? No, we did Tobin. Yeah, we did the Tobin.
The first one was dividend per share we used, though. Just that we would not put ROA in. The first one was dividend per share we used, just that we would not put ROA in the model.
Okay. Okay, so what are we doing now?
Now
we are now
doing dividend per share, but there is ROA in the regression.
Okay, we have done this dividend per share. This is
ROA.
ROA. That means we have not done Tobin Q.
We have not done Tobin Q, no.
Okay, we have not done Tobin Q. So this should have been Tobin Q. So
no, that one.
Tobin Q. I'll bring in Tobin Q and
No, put dividend per share there.
dividend per share. Okay. So this is determinant of dividend, Tobin Q. Determinant of a firm performance.
Firm value. Firm value.
Firm value proxied by
Tobin
Q. Proxied by Tobin Q. Is that okay?
Yeah.
Because
yes,
there are other variables we can use to represent firm's value, like and what's it called, earnings per share, or a market value of the company represent value and represent the value of the firm. So we chose the proxy to represent market what's it called, value of the firm, and that proxy we chose is Tobin Q. Let's note that nuance difference. So this is the last regression, and what's our R square here? I think it's bringing about the highest R square so far.
Yep.
That is
56%.
56%. The F statistics is greater than 2.
Yeah.
Right, Dr. Charles?
Yeah. Yes, it is.
It is.
It has the highest F statistics too, 39.28.
39.28. And it is significant because at 1% is significant, right?
Yes.
Okay. So that is that. So like we have agreed that
then the p-value now.
It's bet will take our analysis from the p-value to know what is significant first before knowing whether it is positive or negative impact the coefficient is having. So in this analysis, which are the significant variable? And at what level? ROA.
Dividend per share.
Dividend per share. What of institutional ownership?
1%, 1.5%.
It's significant.
It's significant, but it's at 5% significant.
It's not up to 2.
It's significant.
It's significant 5%. The other ones are 1%.
Yes.
But it's also you have understood this thing.
Yes, now why?
So that, we are home and dry.
Three variables are significant, and the 3 of them have a positive coefficient.
The first 3 variables are significant. The last 2 are not significant.
They are positive and significant. Okay. That's what I'm saying.
Are you there?
They are positive and significant.
Right.
So I did something the other time. Did you notice this command?
No problem. My door is always open for you.
Please close your door. It's night. Hello? Hello?
Yeah, we are listening.
Yes. Did you notice what I did now? Did you notice this regression that I ran?
Yes, we are seeing it.
Okay. You are seeing it. This is S tab. It's a summary of the significance level.
Okay.
It comes with the coefficients and what's it called? The coefficient. That's the p-value. Let me get it right. Say the t statistics in parentheses. The t statistics in parentheses. That's and the which one is up? The coefficient is up. Three things has been summarized here. The coefficient of ROA, coefficient of dividend per share, institutional ownership. You see that ROA coefficient is having a 3-star. It's a 3-star general. Dr. Charles, are you there?
Yes, I'm here. I'm here. My network is very bad.
Dividend per share is a 3-star general. Confirm.
Yes, confirm. I can see it. Yes.
Institutional ownership is 1-star general.
Yes, a brigadier general. Yes.
So what is the implication? What this smaller table summarizes previous table. It summarizes the previous table. And it brought out the significance. The ones with the 3 stars are the superstars.
Yes.
They are highly significant.
Right, yes.
Highly significant. At
yes.
Positive and highly significant. Positive, highly significant. Whereas institutional ownership is positive but significant at a 5% level. Equity to debt is insignificant. Turnover is insignificant. This is a summarized version of the previous table. That's what I needed to show you. And in some publication, in fact, in standard publication, what you will see is the summarized version, not this detailed version that we used earlier, because the summarized version brings out the most important information. So with this, I think we should be home and dry for today. Question?
Hello,
yeah. Sir. Hello, sir.
Yes.
I hope I understood you with the 1 star. 1 star. 1 star means significant at 5% level only. Is that what you mean?
Very correct. Let me also state. Let me state also as a caveat. You can decide to do it otherwise, as in the other way. Maybe if you are significant at what's it called? At 5%, let's say at 5% is 2-star. Maybe at 10% is 3-star or something. But the most important thing is your definition of what your star is. The definition of what your star is, is at the bottom, is defined, well defined here. The first one says, if a p-value is less than, that's there for 1 star, your p-value is less than or equal to 5%. That's the 1 star. If it's 2 star, your p-value is less than or equals to 1%. And if it's a 3 star, your p-value is less than or equals to 0.001. 0.001. Recall that the p-value for these ones that are having 3 stars are pure zeros. 0 in 3 places. 0 in 3 places, which is less than 0.001. Exactly.
But he didn't explain that didn't explain the turnover on.
What happened to turnover? Turnover
is not in these 3 explanations now.
Turnover is not significant. It's not significant here.
He didn't. He only explained the one that has 1 star. 1 star is a
somebody that has no star. It does not belong to the general club now.
It should be written there now without star. I get it. But it's true now. Because that one is not only this is also negative and insignificant. The turnover is negative.
It's implied. It's just like you stating your null hypothesis only in your statement of hypothesis. Obviously, your alternate is already known. It's either head or tail. So if it is not if it's not in the significant list, it is insignificant.
Okay.
I rest my case, barrister.
It's okay.
Okay, sir. So motion for adjournment.
I move.
I so move.
Thank you, ladies and gentlemen. We'll reconvene tomorrow the same time. God bless you all.
Thank you so much.
Yeah.
We appreciate. Thanks a lot.
Dr. Rajiv.
It's a pleasure.
Thank you so much, Dr. Baraka. Thank you so much. Even though network did not even allow me to enjoy the lecture.
No, but we actually enjoy your company here. Thank you very much.
Thank you. I've gained so much from this session. Thank you.
I appreciate it.